So this is a battery system that we have in our Caravan. It's an inner drive I board, which is a prefab board. They have a number of different prefabricated boards designated by A, B, C, and at least up to I. We've got 3 or 4, I should say, heat producing devices in here. This is the 240 volt charger, which is humming away now. A solar controller here, a DC-DC charger here, and probably the worst of them all is the inverter, which is on the other side. That produces a fair amount of heat on its own. In our case, we stay off grid where possible, so this thing's probably not going to be on a lot, although it's on now. That these two here are going to be on at the same time reasonably regularly, and the solar controller and the inverter is going to be on at the same time quite frequently as well. So we've got 1300 plus watts of solar on the roof, so we've got a fair amount of power coming into the solar controller. It's got a massive heat sink on it, so it's obviously going to generate a fair amount of heat by itself. Now at the moment, the DC-DC charger over here is sitting at about 22 degrees, and the 240 volt charger is now sitting at 38 degrees. So that's 16 degrees difference from ambient. So that thing's, the DC-DC charger is not plugged into the car, so it's completely dead at the moment. So there's a fair amount of heat being bled off this thing here, and so with all these things all going various points in time, this cabinet is going to produce a fair amount of heat. And unfortunately, we've got an east-west bed, and the battery system is located in underneath that next to the couch, and so it's completely sealed. There's no way for air to get into this system apart from bleeding in through the cracks in the cabinetry, etc. So we need to get some air out of it. We need to get that hot air out of it. And to get hot air out, you need to get air in. Air can't flow out if air can't flow in. So we bored a hole. Whoops. Go up there a bit. We've bored a hole down the other end of the battery system near the outside hatch, and that comes through underneath the couch to where the water pumps are, and then through the next division underneath the couch to where the gas heater is. And you'll notice that that's the heat pipe for the gas heater, and at the other end of the cabinet is the air in. So that's not sealed to the outside world, so the air can freely flow in, just in and out of that vent. Yeah, that's where the heater gets its air from. So it'll pull the air, this little fan will pull the air through there, and it will be able to change that air, create a flow from this side of the cabinet at the bottom, and come out over here toward the top, which is where the fan lives. And so the fan's up high, obviously, because hot air rises, so that's where the worst of the heat's going to be, up high, so you keep the fan up there. This is an 80mm fan, so I've bored an 80mm hole through the end of this cabinet. This cabinet's just at the foot end of our bed next to the door, so there's a vent on the outside of that. The fan is screwed to the inside, and then it's wired to this temperature switch, and that's just a Chinese product, which I think was about, I don't know, about $6, $5 or $6 delivered or something like that. It has a remote probe which is hanging down over here, a bit closer to the inverter, and so the set temperature on this particular one, that's, some of the parameters are not adjustable. So this one, it turns on, you preset the temperature that you want, which in my case is 27, and the switch will trigger at 2 degrees above set temperature. So the switch will fire up at 29 degrees, and what that will do is that will close a relay that's built into the board, and it's a fairly highly rated, on paper anyway, it's a fairly highly rated board. The amperage, I think it's about 20 amps or something. These this thing here draws milliamps and that thing draws milliamps. So this thing is more than capable of dealing with it. And so what will happen is once the cabinet gets to 29, the fan will trigger via the switch. It will pull the air out through the fan on the outside, sorry, the vent on the outside, and it will bleed as whatever air it can get, which is the air from coming underneath the couch, which in turn is coming from inside the cabin. So it's got the capacity to reduce the temperature inside this compartment down to ambient temperature and do it reasonably quickly. This fan is a Be Quiet brand fan, which I quite like them. They are well, I can say incredibly silent, but they are just silent. You just don't hear them. This little 80 millimeter fan can pump I think about 27 or 28 cubic feet per minute. And it doesn't take a rocket scientist to work out that we've probably got, what, 7 by 1.5, so you've got about 13 cubic feet of air inside this cabinet underneath the bed. So it's got the capacity to change the air twice a minute and do it silently. So if we crank up put a cigarette lighter underneath the probe, you'll see that thing will flick up to 29, and the fan will turn on. You can see that it's off now. Up she goes. There you go, on she goes. The only thing you hear is that click. The fan itself you don't hear, particularly over the top of the 240 volt charger that's thumping away now. And as soon as that drops back down to its set temperature, which is 27, the fan will turn off. And that red light there is an indicator that the switch is triggered and the relay is now closed. Once it gets to 27, the power will turn off to the relay, and it will open that relay, and then the fan will go off. And that's it, turns off, fan turns off, everybody turns off, and the air temperature in this cabinet, that fan will keep going until that temperature gets back down to 27, and which eventually will, as long as the ambient temperature inside the van is obviously lower than 27, otherwise it'll just keep pumping along. And even though the temperature might stay high inside the cabinet, unfortunately when you're camping and you go away, you don't always have the luxury of having cooler air than that 27 degrees. So that temperature, the high temperature, is going to cause that fan to just stay on. That particular fan's got a life expectancy of 80,000 hours or something ludicrous like that. So that thing can stay on forever. Both of them draw microamps or milliamps. So you can't notice it on the battery system. It doesn't matter turned on or off. There's no indication on the battery system that anything's going on. The benefit, of course, of putting a fan into a cabinet that has the battery system in is that there's 12 volt everywhere you look. So you can plug it into anything you like. That's a fuse box there. So I've just put it into there, onto the same fuse as the stereo of the van, because that likewise draws bugger all, and the benefit is it's got quite a low fuse in there. But as long as you fuse this thing, you can connect it straight to the batteries, and yeah, and it's a set and forget thing. Now that it's done, we can now put these boards over here back on top of the roof of the battery system, and then drop the mattress back down, and that's a set and forget thing. We'll never have to touch that again, and it'll do its best to keep our battery system reasonably cool, or as best as it can, depending on the ambient temperature. And the batteries, electrical systems don't like heat, so the less heat, or the more heat you can draw out of that cabinet, the better it's going to be. And plus, it's sitting right underneath my bed, so less heat means less chance of it exploding, or those lithium batteries vaporising and taking us with them. So yeah, keeping the temperature down is a good thing. I think it's going to help with the longevity of the system. It's going to help with the longevity of the batteries.